Hello everyone, welcome to this video where we talk about the necessary conditions for the seed germination. In the past video we discussed about the various parts of the seed and what is the seed germination. So in this video we talk about the various necessary conditions that are needed for the seed to germinate. So seeds require certain conditions for them to germinate, which are the water, oxygen, optimum temperature, and the light. Let's start with the water. Water enters the seed through the micropyle. Micropyle is one of the part of the seed we talked before. Now the water softens the tester, thus allowing the seed to take in water. After the water has been taken in and softens the tester, the osmotic pressure in the seed causes water to enter the seed by the osmosis. Osmosis, this is the movement of the particles from the region of low concentration to a region of high concentration through a semi-permeable membrane. So the pressure is created in the swollen seed, rupturing the softened tester. So let's see the various uses of water in a seed. The seeds require water for the processes outlined below. The first one is the activation of the enzymes. When the seeds are formed, most plants store a food reserve with the seeds, such as the starch, proteins, and oils. This food reserve provides nourishment to the growing embryo. When the seed imbibes water, hydrolytic enzymes are activated and break down these stored food resources into metabolically useful chemicals that can enable the seed to grow. The second one is that most seeds require enough energy to moisten them, as the uptake leads to the swelling and the breakdown of the seed coat, which enables the embryo to emerge from the cotyledons. The third one is that water is used to dissolve the food substances. The food substances that needs to dissolve in order is to diffuse or get transported to the growth parts of the embryo in the seed. So without the dissolving, the transportation of these food substances could be difficult. So the water is very important. Moving on, let's see the other condition, that is oxygen. Oxygen is required by the germinating seed for the metabolism. It is used in the anaerobic respiration, which is the main source of seedlings energy until it goes to provide those leaves. Now, the respiration produces energy for the processes like the cell division and the transport of food to the growing regions. Oxygen also diffuses into the seed through the micropyle that softens the tester, later allowing oxygen to diffuse directly into the tissues of the seed. The other condition necessary for the seed germination is the optimum temperature. The temperature affects cellular metabolism and the growth rates. The temperature is an important requirement for the activation of the enzymes. The enzymes in the seed work best at the optimum temperature. These are initiated by the high temperatures and inhibited by the extremely low temperatures. So some seeds may require the first exposure to the low temperatures before they can germinate. This is usually in the case of those plants that grow in the temperature regions. Now the seeds needs to go through winter before the onset of the spring, when these seeds germinate. So these are the conditions. The last condition necessary for the seed germination is the light. The requirement of light for the germination varies from plant to plant, as some plants need darkness while others need light in varying degrees. Light or darkness can be environmentally triggered for the germination in the type of physiological dormants. So most seeds are not affected by light or darkness, but many seeds, including species found in the forest settings, will not germinate until they are in the opening. The canopy allows sufficient light for the growth of these seedlings. So those are just of the few of the conditions necessary for the seed germination. Moving on, let's see the types of seed germination. There are two types of seed germination, namely the hypogeal germination and the epigeal germination. Let's start with the epigeal germination. The epigeal germination, this is the type of germination in which the cotyledons are brought above the soil level. So this type of germination is seen in many dicotyledonous plants such as beans and the sunflower and the others, while some of the monocotyledonous plants such as onions also show this epigeal germination. While the hypogeal germination, this is the type of germination which the cotyledons remain underground. So it occurs in plants such as the maize, peas, wheat, and the others. So in this hypogeal germination, the part of the embryo that elongates the epicotyle elongates rapidly, raising the pumil above the soil, while the cotyledons remain below the ground level. So that's all for this video. Thank you for listening.